Hey, I'm Amar.
And I'm Matthew.
And this is Our Side of the Coin. Hey guys, welcome back to another week of Our Side of the Coin. We actually brought up a couple guests in this week. Meet Casey and meet Christian. They're going to try to convince us that the Earth is flat this week.
Yes, we are very argumentative and like to try and convince people of things that may or may not be true.
But this one is definitely one of the ones that's true. Don't get me wrong there. This is one of the true ones.
So we're going to let Matthew ask the first question, and we're going to get some answers from him and see if they're actually able to convince us.
Okay, what do you have to say to the fact that there's a lot of photographic evidence of the Earth being a sphere?
There's a lot of photographic evidence of the Earth being flat as well.
There is photographic evidence from space that the Earth is a sphere.
Look at the horizon. Use your own eyes.
Time out. So remember the recent Mars rover pictures that we have seen?
Yeah.
They used a fisheye camera. That shows NASA's preference to fisheye cameras, you see. So if they use a fisheye camera to take a picture of the Earth, then it would appear around it. And it would also support the global conspiracy to make people believe the Earth is round.
All right, okay, and then the second part of that is to take a photo from space, you need to be in orbit. How do you explain orbits if the Earth is flat? The gravity would be different depending on different areas.
There is no gravity. Gravity is caused by the universal accelerator pushing everything up at 9.81 meters per second squared.
Okay.
So wait, explain that a little bit further. If I were to drop a pencil, it still falls, right? So what is the upward acceleration?
Well, that's because it's not massive enough, you see. Yeah, so it's either objects are too dense or they're too massive, or they're just not connected to anything, you see. Like if you were to have like an object, like if you were to have like for example, this box of checks. It's not massive enough, you see, to be considered worthy of upwards acceleration. So when we're connected, when we're connected to the Earth, we're getting shoved up by the Earth, but we ourselves are not worthy of it.
So why is the Earth? So the Earth is worthy of accelerating upwards because it's massive. And what else do we know scales proportionally directly with mass? Gravity.
Force. Yeah, I mean, but gravity scales with mass because they needed a way to explain away the universal accelerator.
So do you think round Earth is just a giant scam by the government?
It's not the government, the governments. It's
Okay.
it's
Scam. It's multinational.
It by the entire world. They collaborate. The governments of the world collaborate to try and keep the populace ignorant and try and convince them that the Earth is
So
indeed.
you're telling me that the world is not able to solve the Israel-Palestine conflict, yet they can convince everybody that the Earth is round?
Yeah, because NASA is the is actually the head of the entire Earth.
Yeah.
They've cut their own funding in order to hide it. They don't have any. They have no interest in the measly issues of Israel and Palestine when the entire Earth is when they're trying to convince everyone that the Earth is round in order for their own personal.
And what do they stand to gain from telling us that the Earth?
Well, we don't know. If we knew that, then obviously we could take them to court over this, right? We could sue them, which of course that would get swept under the rug. I'm sure someone at some point has found that out, but the entire court system was like yeet to that case.
Israel and Palestine have a secret agreement to stay hostile to each other because it benefits the governments of both to have an enemy to work against. That way the Israelis can say, hey, the Palestinians are coming, like, vote for me, I'll fight against the Palestinians, and the Palestinians can say the same thing against the Israelis. They need each other, so they have a secret behind closed doors agreement.
And he's not just saying this; he's a Jew. Like,
trust me, I have first-hand experience.
Okay, that might be cut. Matthew, remember to do this later. Okay, and so if gravity is in reality just a universal acceleration of just 9.8 meters per second.
8.1.
9.81, some other numbers that don't matter because of significant digits, meters per second. Then how do you explain the orbits of the moon, or the orbits of the Earth and the moon around the sun, or any other orbits that exist?
They're spherical.
So they're orbiting around the Earth because of dark energy. Dark energy is constructed in such a manner that it ends up forcing things in order to go in the manners. There's also significant magnetic field lines around the entire solar system, in which planets appear to be moving out.
Have you had any evidence of these magnetic lines?
Well, obviously they move.
But you would be able to detect
So,
them.
all right, so planets have metallic properties to them, yeah?
Not all of them.
Most of them.
All of the ones that we've found.
Yes.
Okay.
So, they move around on magnetic lines that exist because of weird dark matter stuff. It has a bunch of quantum physics that, it's kind of complicated.
Okay,
not
so
gonna get into
these
that.
magnetic lines come from the metallic cores of all the bodies, or just the
No,
sun?
these metallic lines are pre-existing, yeah? So
They
the
just
planets
are.
just move along them because of their metallicity.
Okay, well, if the Earth is flat, what's on the bottom?
Australia.
Australia?
Now, explain to me, if Earth is moving at an upward acceleration of 9.81 meters per second, how have the people in Australia not fallen off?
They have ground harnesses.
Excuse me? Have you been to Australia?
Have you been to
I am
Australia?
not.
Yeah,
exactly. See, you cannot confirm or deny. They have harnesses that are connected to the ground. See, one time on 4chan, I saw a story.
And this is being cut from the podcast. Okay, continue.
I saw a story about how someone was invading Annan's house, or was going to invade him, but Annan noticed that he had a rusty hinge on his ground harness, so he threw his boomerang and broke the hinge, and they ended up falling off.
Yeah, exactly.
Okay, so
Okay, so
how does it rain in Australia? Does it rain in
Oh, that's the
Australia?
ocean's falling.
Salt water.
Yes.
Salt
No,
water.
because there's
around
ocean
here.
that surround Australia, right? So that's the ocean falling out, and then it's like, oh wait, there's a dark energy like bubble around
Pushing
the Earth,
us
and then when the water goes down, it gets shot back up.
Okay.
So how is there an atmosphere in Australia?
Well, water, planets. Yeah.
What do you?
Because
Because the atmosphere
the
is
atmosphere
getting
gets pushed up too.
the atmosphere, the atmosphere is held by gravity. Oh, there's no gravity. The atmosphere is getting pushed up. Fine, but on Australia, the gravity is going the other way, so the atmosphere
It's
should
not
just
going the
fall
other
down.
way. It's going the same way.
No, you're going up. Australia is down. So
Well, that's because there's dark energy that's
It's-
pushing up
It's
on
a-
Australia.
the Earth is a disc,
Yeah.
and Australia is on the bottom.
Yeah.
Everything is moving up,
yeah.
so the atmosphere is beneath Australia, but
Yeah.
moving up at the same rate as Australia.
So why do they need ground harnesses if the people aren't just also moving?
Well,
up,
because
up,
the
and then-
people. All right, so what would happen with the people is essentially they'd fall into the atmosphere and then they get shot back up. But you don't.
It's a circular motion. It's
Because then
convection.
you
Hold on,
don't
what
don't
if-
want to fall back
What
down.
did the
It's
people of
convection.
Australia do? Because there are native people from Australia. What did they do before they had ground harnesses?
They always
So
have-
actually, the native people of Australia were people who ended up finding the edge of the Earth and they're like, "Hey, what's over here? This seems pretty cool." So what they did was they hooked themselves to the Earth and started climbing down. And then they had a boat that was like anchored to the Earth and they kept like having to put a stick on the bottom of like,
Yeah,
or I guess
they
the
push.
top in this scenario, and like push themselves along like this.
What? Okay. Alright, so if the Earth is a disc, right? What prevents it from continuously spinning over itself within space and knocking everybody off anyway?
Because the universal accelerator is accelerating it like in direction upwards, and since the Earth has been around for so long, the velocity of the Earth is so high relative to like space, so that relative to the like
Relative
lateral-
to null.
yeah,
Okay.
like relative.
Yeah.
So that keeps it stable.
So,
Okay, go ahead.
how much is actually being accelerated by this universal accelerator? Because so you would have to argue the whole solar system is moving up at 9.81 meters per second.
All significant celestial bodies, yes.
What counts as a significant celestial body?
Well, obviously Mars,
What do you think?
Sun. Yeah, what do you think? There's just the rocks that are bigger than you'd expect a rock to be.
How big do I expect the rock to be? There are plenty of rocks outside. Why? If I were to throw
We
them-
haven't measured the exact numbers.
Yeah, but it's something. It has something to do with its size. Obviously.
Yeah.
Okay, now, there's been many instances where meteors have struck the Earth, right? And essentially, if the Earth was flat, would not these meteors not cause the Earth to spin over itself?
So you see, what happens is as the Earth gets closer to the dark matter that's pushing it up, and more like the pressure of dark matter is higher, it starts to like stabilize it. So really, it get hit, but then it'd be like, oh, woo! So if you didn't, for the listeners out there, I was moving my hands like up and down, like one time, while simultaneously the other one went I.
Just imagine it, viewers,
Viewers.
watchers, readers, listeners. I don't know. Okay, so there is a dark energy field around all the Earth.
Under it.
Just under.
Just under. Yeah, because otherwise it'd be like standing still. Stop.
Okay, now explain how you could leave the Earth's atmosphere if we're surrounded by dark matter as such.
Because there's no dark matter on top of us.
But what about launches from Australia?
We haven't launched anything.
Yeah, Australia doesn't have a space program. Wonder why?
Because kangaroos can't fly.
So potentially, if the Earth was hit with a large enough meteor, it could get into the dark matter itself.
Yeah, that's what happens with the dinosaurs. You see. So what actually happened is we got hit by a meteor. And all Pangea was all the way on the top. So what happened was we got hit by a meteor and it pushed the Earth down. But then the Earth was like, woo, back up again. But
he moved his hands again.
It didn't have constant acceleration while it was going upward. But the dinosaurs got to a certain velocity, and then they just got yeeted off the planet into space.
Have you found any space fossils yet?
Well, we haven't done enough asteroid
behind us because we're moving.
So why are there all of these land fossils?
Because
obviously not. Because some of them were still over the Earth when the Earth caught up to them, so they landed on the Earth still.
What's your evidence that
if the Earth is flat? I'm getting to that right now.
Okay.
If the Earth is flat, then how do you explain the fact that ships or anything moving beyond a certain distance seems to dip below the horizon?
That's actually an interesting phenomenon. So it's a trick of the eyes. You see. So as they're moving towards the horizon, obviously you can't sink, and then they sink into the water. That's just stupid, right? So what they do is that as they move towards the horizon, what happens is the horizon line is getting closer and closer, but it's not actually an infinite distance away. It's a finite distance away, you see. So what happens is it passes that finite distance, and then we just can't see anymore.
Wait,
our eyes tune it out.
Wait, hold on a second. If it went over the edge, right, now wouldn't it have fallen off the Earth?
No, because obviously we can't see the end of the Earth. The Earth is fucking massive.
Yeah,
so
I get what you're saying. I get what you're saying. Okay, so our eyes just tune out light past a certain distance.
Yeah.
And
we can't see that far.
Cameras also do the same thing.
Yes.
Why?
Well, because you can only have so much light per pixel, right? So as it
pixel. Your eye is measuring pixels, by the way.
So essentially, once it's less than half of a pixel, it disappears.
That shit blocks out light, or at least it doesn't emit as much light as just a pure beam of light. So there's no way moving farther would add more pixels. It'd still be the same amount. There'd be less.
Yeah, it's becoming less of the ship is becoming less of a portion of the pixels, right? So as it becomes a certain point, cameras are programmed to just delete it, pretend it's not there. You see,
the whole
because otherwise then you get inaccurate. Your error bars would be clogged. Right?
If you got a real camera, it would show the real thing. But the governments regulate the cameras. You're not allowed to make a camera without this
coding,
this secret coding.
Okay, wait a second. So what about all those people who circumnavigate the globe?
They go in a big
went around the edge.
They went around the edge.
Yeah.
Yes.
But they passed over Australia and Africa.
They didn't. No, they went.
They did not pass over Australia. If they did pass over Australia, they would have to have been accelerating upward really quickly, and that would be too dangerous.
Right? But that's exactly my point. People can fly over Australia.
No, they don't.
Oh no.
Sure they do.
Offer proof.
If you fly from Detroit to not South Africa. What's a good country to pass it over? If you fly to Australia, what's going to happen to your plane as you cross over the edge?
Oh, as you cross over the edge, they actually switch you to a new plane.
Say what?
Yeah, they switch you to a new plane that's hooked onto a little railing that's having it hanged from the bottom of the.
But the railing's invisible.
Yeah. Well, no, the railing's still there. It's just underwater.
Okay, here's another question.
But you can't see the.
Yeah, they're using really strong fish wire.
Here's another question about the atmosphere. If it's not gravity holding the atmosphere, it's just an acceleration, then why does the atmospheric pressure decrease as you go up? It decreases because gravity gets weaker as the distance increases. So why, if you're just moving down 0.8 meters per second, why does the atmosphere decrease?
Oh, well, because obviously, so obviously Earth has been hit with, meteors before and stuff, and we're, still detonating things that, make it a little bit wiggly. So when it becomes wiggly, different parts of the atmosphere are at different heights and different pressures from the dark matter. So the air from those like
Wait.
highly condensed parts ends up getting pushed away, as is normally observed with atmospheric differences.
But there's no dark matter on top of the Earth.
There's not, but it's all powered from the bottom of the Earth, you see. And because the entire atmosphere is not like accelerating uniformly upward, it's relying on pressure pushing it upward, like pressure from the air, then it will...
the reason why is the lower atmosphere is being accelerated faster than the upper atmosphere. And then, so the lower atmosphere becomes the upper atmosphere, and then it just keeps on going on top of it.
And then the little like wiggliness of the Earth.
Why is the upper
causes
atmosphere being accelerated slower than the lower atmosphere?
Well, because obviously it's not getting pushed on by the dark matter directly,
As
such as
much.
the lower atmosphere.
Okay, so if there was farther away.
Okay.
Okay.
Let me bring up a historic case. So Ferdinand Magellan was the first person to go around the globe, correct?
Did you know he actually didn't do that?
He didn't complete the trip. However,
Yeah.
right, he still was able to
His
get
ship
most
did.
of the way. His ship did.
Yeah.
So why didn't his... And this was pre-railing, right? So how did he go over...
Well, how do you know it's pre-railing?
We don't
Wait.
know when it started.
When were trains invented?
Trains?
Yeah,
You don't need
railing.
Yeah,
What kind
yeah.
of railing are you looking at?
That's the first time that they found that specifically used for railing. It's like we're
So how old is this railing, and why hasn't
We
it
don't
raised?
know.
we have no idea. It
We haven't been
it
there.
could be that Martians came and installed it. We don't know.
Okay, how do you explain the fact that Earth casts a circular shadow onto the moon?
Oh,
It's
so
a
there's
circle.
yeah. So actually, that's
No,
weird.
not circular, a spherical, because it looks like that.
So there's actually a disk, or a disk or other celestial object. We haven't quite identified it yet. That during like lunar eclipses, I believe you're referencing, right?
Yeah.
Is passing in front of the moon, and it's almost all black, so it's very difficult to
It's
identify
black, so
properly.
it just looks like it's
Then
a
we would
shadow.
be able to see it by the fact that there's just a hole where there's
Wait,
no
wait,
So
where-
it
where is
only
this-
comes at the exact times of lunar
We would
eclipses.
still
That's
be
what a
able to
lunar
measure
eclipse
it.
is.
There are lots of people looking at lunar eclipses.
Yeah, well, it's a. I mean,
That's
obviously,
why it
yeah, we
looks
measured
black.
it. We measured it, and it's approximately the same size as the Earth, right?
Wait, so where is this thing in space? Is it or
We don't know.
It just
So it's just there, somewhere in
It's
space.
somewhere. It's somewhere in.
And it
space.
happens.
It's kind of hard to see a black thing when there's like already when you're looking at black. Like it's kind of like black hole. looking at
According
shit.
to your round Earth gravitational theory, the Earth would have to be at such a specific distance away. The Earth and the size of the Earth and the distance of the Earth from the Moon and the Sun and the size of the Sun and the Moon would all have to be such a precise, specific values to get to make it so that they eclipsed like each other perfectly. Because like
Isn't that why they're so rare?
no, because but like in like according to your theory, in like 1,000 years, there won't be total lunar eclipses because the
moon will have
the
moved a
moon will have,
sufficient distance away.
exactly. So you'll
But it'll
still be able to see
still-
it.
but
That
if we're
the
going
point
on-
of time that would take, we'd have to be in such a precisely specific point in time. There's no way that it makes much more sense that there's something that it's not moving away. There's something that's blocking. it.
I would
Welcome-
argue it makes
welcome-
a lot less
welcome
sense
to
that there's a
Razor.
magical object that just
It's not
appears.
magical. It's not magic. It's science.
Okay, let's just
Trust me. I've watched Bill Nye the Science Guy.
I would argue that there is a higher chance that we don't know anything about an object just appears, rather than the fact that, because you said it's highly unlikely that like the moon is the same distance away from the Earth as it is smaller than the sun. True enough, but it's non-zero.
There's a non-zero chance that there's something that
There's a lot
There's
smaller
a non-zero chance I have of a. You don't know that.
You're cutting that out. You're cutting that out.
Christian is male, by the way.
Don't touch the microphone.
Oh boy, we have to readjust that.
This is horrible. Okay. What? Go ahead.
What do you mean?
Wait.
This is perfect.
What does that mean?
Wait,
There's a non-zero-
hold on. What are we
Anything has a
referring to?
non-zero chance.
He said
There's a non-zero chance of anything. You can't say there's a 0% chance.
Okay, fine. Okay.
There's
You're arguing
like
that-
say like whatever you wanna whatever statement. There's always a non-zero chance of it being true.
Yeah, but the chance
So
that there's
there's-
an object in space that we haven't noticed yet is significantly less than the precise measurement.
How do you know?
What's your
it's just
your
a
Because
so
we're
long
going
to identify black
because
holes.
we're going off of what we know. And so far, you have told me you know one thing about this object, is that it appears. And it just
is that wrong?
We know a lot more things
lied
about
to.
the sun and the moon.
Right, but what about the theorem? The theorem that things are derived off of. I could invent an entirely new system of mathematics and then call it good and then learn a ton about it. Like reinvent the quadratic formula, reinvent calculus in this mathematical whatever. It doesn't make it true.
Okay.
So if I know more, what you're essentially saying is that if you know more in a made-up system of math than we do in our math, that made-up system of math is more valid.
But that's relevant for both flat Earth theory and round Earth theory.
If your made-up theory of math works, then I don't see why it's not.
We can prove.
I'm trying to argue that your made-up version of reality does not work.
But it doesn't. It would work consistently with its own rules, but it wouldn't work consistently with the
rules you've been lied to. Because 1 plus 1, we can actually prove that 1 plus 1 does not equal exactly 2.
In some scenarios, not in all.
In some scenarios, it doesn't equal 1 plus 1 does not equal exactly 2.
Yeah, because to begin with, those are arbitrary units that humans define. All right. Well, I mean, okay. The thing with round Earth is that based on what governments have told us.
Yes.
Based on what science has so far told us.
The science that you've been taught has told you. Yes.
Yes. We believe that the Earth is round. And there has been photographic evidence from the moon showing the Earth as a sphere. Was that...
You mean the moon landing that is highly controversial and might not be true? In fact, I would argue that there is a significant probability. Maybe it's not probable, but there's a significant probability that it was false.
There were a couple...
There was a falsified moon landing.
You can fake pictures.
I get that, but
and you have been since photographs.
Yeah, remember that thing where Stalin photographed out Lenin or cropped out Lenin.
Yeah.
Yes.
That was before the moon landing. So it shows that we had the capability during the moon landing.
Editing photos during when the moon landing.
So is the moon round?
The moon has been confirmed to be round. Yes.
Spherical.
Okay.
Why is
the sun round?
Has been confirmed to be spherical.
Why would the Earth not be round?
Oh, I remember.
Because it has not been confirmed to be the sun.
Time zones. Explain them.
So obviously the sun cannot illuminate the entire surface of the Earth at one time, right?
Yeah, it can.
Sure, it can. If it's flat.
If it's flat, why not?
No, because it's not that bright.
Oh, yeah, okay, we don't.
It's not directly over here, so it's not illuminating. It's it's coming up, and it's oh hey, my trig is gonna hit someone here, and
there will still be some light.
So.
There is some light.
Obviously.
Does that mean Australia is always dark?
Oh no, not when the sun's on the bottom of the Earth.
That's what night is.
Yeah.
Wait, so explain to me what way the Earth is tilted relative to the sun. Is it like this, or is it flat? So is it? I'm for the listener. for the listeners, I'm showing my hands, and both are either vertical, representing that the Earth faces the sun, or if the Earth is horizontally.
Is the Earth parallel to the sun or perpendicular?
Yeah,
to the sun?
yeah, better way to put it.
Perpendicular.
Okay, so how do you explain time zones? Because half of the Earth is in day, half of the Earth is
if it's going in
a magnetic... obviously, because the sun is not bright enough to illuminate the entire Earth at the same time.
You should be able to see...
The Earth is...
You should be able to see...
The sun is relatively small.
It's relatively not bright. The inverse square law of luminosity has caused it to not be super bright all the time in all areas of the Earth. So,
oh my god, how huge is the Earth?
It is
very.
It is large.
We haven't been able to measure it exactly, but
that's.
I feel like that's not correct. Because regardless of whether, how do you explain that we know the circumference of the Earth, don't we?
We measured that from the sun and how much it moves.
We measured that from the sun using the model of the spherical Earth. So we very well could know the surface area of the Earth. Except if they released the surface area of the Earth, they would have to have units attached. Otherwise, it wouldn't be properly scientific paper. And if they had units attached, then we could see it was in meters squared.
The Earth, but that's surface area. That's just taking down a 3-dimensional figure down to a second dimension.
Also, topology. Topology, you see, states that things happen.
That's not helpful. What things?
You're talking about mountains. I don't think they make that much of a difference because the Earth has to be huge for the inverse square.
That's topography, Matthew.
What's topology? Is like the shape of
a graph in mathematics.
Effects.
So if you have a if you have a spherical Earth, then there's no way to accurately express that as a flat. As flat. There's no way. Yeah, that's basic law of topology.
Yeah.
So, therefore, the whatever surface area was derived of a spherical Earth would not apply to a flat Earth.
So you're saying we have no units?
We have science. Science has stopped us. The science of NASA has stopped us from accurately finding the surface area of the Earth because they are commie scum.
I feel like this has gotten a little ranty.
Yeah. Alright, yeah.
Move on.
Well, thanks Casey and Christian for stepping in. If you guys think that they provided a convincing argument, leave a comment or leave a like. See you guys next week.
Shout out to the Flat Earth Society!
If you want us back, also comment and
like
stuff.
Flat Earth Society has members all around the globe.
All around the globe?